Hey everybody, it's Ripley back again. We're going to talk today about 12.1, which is sequences. Now, not to besmirch the author, but he or she chooses to use some notation that I don't necessarily agree with, and it isn't consistent with the way in which we define things in calculus. So I want to make sure that I give you some the information that I want to see you be able to use, that I want to see you be able to use, or be able to talk about and to write about when you're doing mathematics. So we're going to talk about sequences. All right. Now let me write the definition that your author, your esteemed author, uses. Your author defines a sequence. So this is a definition. He defines a sequence as a function whose domain is the set of positive integers. Is the set, man, this thing's lagging today, right? Of z positive. This is just the notation for the positive integers. Now, I don't agree with that, and I'm not going to get into ticky-tack reasons why. Okay, but what a sequence is let's rewrite this sucker in black. What a sequence is it's a set. It's not a function. It's a set. All right, whose elements are determined by the range of a function with domain of positive reals. And I know that sounds really ticky-tack and kind of wordsmithy, but it's, the devil's in the details, as they say. The function with domain, I may have to shrink this back down, of z positive. All right. Now, check this out. What a sequence is you'll often see a sequence written like this. All right. And what this really means is you've got a set. That's what these brackets means. It's just a box. Think of it as a box. And the elements, the things that go into the box, are ordered. So you got A1, notice, A2, A3, A4, all the way up to AN. And you get to stop working as soon as you get to the n value that you've decided on. It could be 17, it could be 17,000, it could be 2. It doesn't really matter. All right? So think about it this way. If I let A sub n equal f of n, which is going to equal, say, 1 over n. All right? Now, basically what I want to instill in you right now, because this is going to be really useful when you get to calculus, is what we do is we simply take a function, f of x. Let's say f of x equals 1 over x. And then we know what f of x equals 1 over x looks like. This is going to be badly drawn, but you wouldn't expect less from me, would you? Don't be petty. All right? And I know that this right here, let's call this 1, let's call this 2, let's call this 3, let's call this 4, etc., etc. And then this point right here is 1 comma 1. This point right here is 1 comma 1/2. This is 1 comma 1/3. This is 1 comma 1/4, etc., etc. So what a sub n looks like is it's 1 plus 1/2. Whoops, not plus, excuse me. It's just a set. Nothing's being done. When I add them, I end up with a series. So I end up with a 1, that's a good little instructional lesson. 1/2, 1/3, 1/4, etc., etc., all the way up to 1 over n. And n is defined by s, or you're told what n is. So do you see the difference there? The author defines it as a function itself, but it's not the function. It's the range of the function. Remember, a function is just a rule that assigns y values to x values. So I know it seems a little wordsmithy. I apologize. So think about this. Try this one. Let's let a sub n equal, I don't know, the set of 1 over 2 to the n. All right? So what would that set look like? Well, it's easy, right? I mean, you let n equal 1. So your first one's going to be 1/2. Your next one's going to be 1/4. Your next one's going to be 1/8, 1/16, dot, 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 and then 1 over to the n. We get to define whatever n is. Sometimes n goes to infinity. I'm allowed to do it that way. All right. Typically, we use lowercase letters to denote sequences, and we use them in series, which is the sum of all these terms. All right. So you could see a b sub n, or you could see like a c sub n. Let's say that b sub n is equal to the set of, I don't know, n squared minus 1 over n plus 2. All right. So what would that look like? Again, plug 1 in. What's my first term? It's 0. So the first element in the box is 0. Now, remember, 0 is an element. It's a number. It's not the empty set. The empty set is a box with nothing in it. Okay? Stick 2 in there. What do I get? I get 4 minus 1 is 3 divided by 4, so I get 3/4. My next one would be, what if I stick 3 in? I get 8/5. 8/5. If I stick 4 in there, what? 16, 15/6. 15/6. Etc., etc. And sometimes I may ask you to reverse that process. You see what I mean? I may ask you to, I don't know, like, what would happen if I did this? What if I said, let's let C sub n, let's let this series be, I'm going to ask you to find the rule, okay? So let's say that this is, let's go, I don't know, let's go 2/3. And then let's go 3/9 and 4/27 and 5/81. Yeah, I know, it's 81st. Leave me alone. All right, what's the rule? What does C sub n equal? Well, what's the function? Well, think about this. This is when n equals 1, because this is C sub 1. This is when n equals 2, because this is C sub 2. n equals 3, C sub 3. n equals 4, C sub 4. Now you may say, Ripley, why'd you have to write all those? Well, it really helps to see the pattern. What is C sub n? Well, when n is 1, the top is 2. When n is 2, the top is 3. When n is 3, the top is 4. When n is 4, the top is 5, etc., right? So what are we doing? Well, the top is just take n and add 1 to it. Right? What's the denominator? When n is 1, 3. n is 2, 9. n is 3, 27. You can see that this is over 3 at the end. So I may ask you to be able to do that. Okay? Now there's some notational stuff that I'm hoping that you've seen before, but you're going to see it again, just so I want to make sure that you're comfortable with it. And there's a couple of fun rules that you might have to deal with from time to time, particularly in calculus. Excuse me, I'm parched. Well, let's talk about what n factorial is. What is n factorial? N factorial is n times n minus 1 times n minus 2 times ... 2 times 1, right? Now, in this case, what I've written, what does this assume? This assumes that n's bigger than 5 or whatever, but I mean, if I have 4 factorial, then it's 4 times 3 times 2 times 1, etc. If I have 17 factorial, it's 17 times 16, times 15 times 14, times 2 times 1. In other words, it goes all the way down. Factorials get so out of hand so fast. All right, now I want you to think about something here. Do you notice that 4 factorial is 4 times 3 times 2 times 1? But what's 3 times 2 times 1? Isn't that 3 factorial, right? So could I rewrite 4 factorial as 4 times 3 factorial? Could I also rewrite this as 4 times 3 times 2 factorial? I mean, look over here. It's easier to see over here. This is 17 times 16 factorial. I could also write it as 17 times 16 times 15 times 14 factorial. That gets helpful algebraically down the road a little bit when we got to start doing some shucking and jiving to cancel some terms. All right. So another way to write n factorial is I can rewrite n factorial as n times n minus 1 factorial, or n times n minus 1 times n minus 2 factorial. Now that factorial is only dealing with this term. All right? That gets a little confusing in terms of PEMDAS. How about what's 0 factorial? Well, if you may or may not know this, but when we start dealing with permutations and combinations, or combinatorics, the number of ways in which we can order things, n factorial is the number of ways that you can order some n things. Like if you have 4 books and you want to arrange them on a shelf, then there's 4 factorial ways to do that. Or what's that? 24 ways to order 4 books on a shelf. Think about it. How many ways is there to order no things? Well, 1 way. Don't order them. All right? So 0 factorial, if you think about it in a combinatoric way, then it's relatively obvious that there's only 1 way to arrange things. However, there's kind of a clever proof. If I think of if I use, let me change my colors right here. If I use this rule, this little property right here, and I think about 1 factorial, well, doesn't 1 factorial have to equal 1 times 1 minus 1 factorial, which is 1 times 0 factorial. So what must 0 factorial be? It's got to be 1. That's a useful piece of information. Okay?